Jump Game 9, from each index you may jump right to a smaller value, or jump left to a larger value. For every starting index, report the maximum array value you can ever stand on. Example from the statement, start at 0 with value 2. Jump forward to index 2 because 1 is less than 2. From 2, jump back to index 1 because 3 is greater than 1. You have reached the global maximum 3, so ANS at 0 is 3, the other starts also reach 3. Second example, from index 1 you can only jump backward to 0 where the value is 2. You never reach index 3, so the best value from starts 0 and 1 is 2, index 2 already holds the maximum 3. The question is the largest value in nums you can reach from each starting index using the allowed jumps. If the story stopped at the tallest bar seen so far on your left, one pass would be enough, but this problem asks for more than that snapshot. A jump to the right is allowed only if the destination height is strictly smaller than where you stand. So you cannot simply leap onto the taller bar next door to chase the global peak, that greedy hop is illegal. You need a different idea, use shorter bars ahead as stepping stones. We still sweep left to right and record the tallest bar encountered up to each index, the prefix maximum, your running trophy. That value is necessary, but by itself it is not always the final reachable peak, it is the baseline you compare when you decide whether a bridge exists. When a shorter bar exists somewhere to your right, treat it as a portal, jump forward into that dip, then you may jump backward toward a taller value. On this example, hop from index 0 to the low bar at index 2, then from 2 leftward to index 1, that 2-hop shape is how you connect toward a higher peak without an illegal direct chase. Sweeping from the end, keep one number for everything strictly to your right, the minimum height there, the shallowest ground ahead. If your prefix trophy is strictly higher than that floor, a bridge exists and you take the best value already computed one step to the right. Otherwise you stop at your prefix maximum. That is the comparison you encode in code. First pass left to right. Carry the running maximum of nums and write it into pre at every index. That is the trophy each position could still claim from everything seen since the start. Second idea, from the right, track the minimum value seen so far as you sweep. Before you absorb nums at I, that running value is the deepest floor strictly to the right of I. The last index has no right neighbor, so its floor is infinity. Connection test at index I, compare pre at I to the floor strictly on its right. If pre is larger, there is a lower bar ahead under your prefix peak, so the jump rules allow chaining into the suffix. That is the bridge that lets the trophy propagate. Filling the last column of the answer row. There is no stretch of array to the right to borrow a better peak from, so the value you place here is exactly the prefix maximum already computed for this position. Moving left one step. The running maximum on your left up through this column is 9, and the shallowest bar strictly to your right is 5. Because the left score is larger, the reachable peak from here matches whatever optimal value you already committed in the column immediately to your right. Moving left one step. The running maximum on your left up through this column is 7, and the shallowest bar strictly to your right is 5. Because the left score is larger, the reachable peak from here matches whatever optimal value you already committed in the column immediately to your right. Moving left one step. The running maximum on your left up through this column is 6, and the shallowest bar strictly to your right is 5. Because the left score is larger, the reachable peak from here matches whatever optimal value you already committed in the column immediately to your right. Finish the row with the same comparison at each position. In this example, every remaining slot still picks up the value already fixed to its right. Done. The answer row is the maximum reachable value from every start. You only touched each index a constant number of times across the passes. N is the length of nums. Time is O of n, one forward pass fills prefix maximums, one backward pass fills answers while updating the minimum over height strictly to the right. Space is O of n for those two arrays, plus constant extra for the suffix minimum scalar. Pseudocode for max value. Build prefix maximums left to right, then walk backward. At each index, either inherit the answer from the right when your prefix beats the suffix floor, or cap at the prefix value, while updating the suffix minimum. Read the array length. If there are no elements, take the early exit. Return an empty list. Initialize the first prefix maximum. Sweep right to fill the rest of the prefix table. Each cell stores the tallest bar seen so far from the left. Infinity seeds the minimum over height strictly to the right of the scan line. Allocate one answer slot per index. Walk backward so positions to the right are already resolved. The last index has no strictly rightward suffix. There the answer is the prefix maximum alone. Otherwise compare your prefix against the suffix floor. If the prefix is strictly higher, a bridge exists toward the right. Reuse the best value already computed at index I+1. Otherwise you cannot improve this start from the rightward chain. Cap the answer at your own prefix peak here. Fold the current height into the running suffix minimum. Return the completed answer array.